The Higgs boson is a massive scalar particle with zero spin, even parity, no electric charge, and no color charge that couples to mass. But that's not all. This bad boy is also highly unstable. The moment it comes into existence, it starts decaying into other particles, spreading its mass all over the place. This particle was first spotted in the wild on July 4th, 2012, thanks to some seriously powerful particle accelerators like the Large Hadron Collider. But the real brains behind this operation were a bunch of physicists back in the 1960s, including Peter Higgs, who gave this particle its name. These guys came up with the idea of a symmetry-breaking mechanism, which is just a fancy way of saying, let's shake things up a bit and see what happens. The Higgs boson is like the VIP of the Standard Model, the theory that rules particle physics. It's so important that it took them over 30 years and a boatload of cash to build the experimental facilities needed to find it. And let me tell you, this particle is worth its weight in gold. It's like the glue that holds everything together, giving mass to all the other particles. Without it, we'd all be floating around like a bunch of ghosts. The graviton is this crazy particle that's supposed to be like the key to understanding the whole damn universe. You see, gravity, everyone's favorite invisible force, is what's called a quantum field theory. And in this theory, every time there's a force-carrying interaction, there's a little particle making it happen behind the scenes. That particle, my friend, is the graviton. Think of it like one of those dudes in a spy agency who pulls the strings and makes all the missions possible. Except in this case, the graviton is messing with the fabric of the universe, bending space-time and making sure we all stay glued to the ground. Now, here's where it gets really interesting. There's this thing called string theory, which some smart folks think is the ultimate theory of quantum gravity. In this theory, the graviton is what's known as a massless state of a fundamental string. That's just a fancy way of saying it's a total ghost, without any mass, electric charge, or baggage. But despite its humble appearance, the graviton packs a serious punch. It's what's called a spin-2 boson, which is like a superpower that allows it to influence the very structure of the universe, bending and warping it like a funhouse mirror. And it moves fast, my friend, at the speed of light. But here's the mind-boggling part. Despite all our high-tech gadgets and powerful particle colliders, no one has ever actually seen a graviton. It's like they're playing the ultimate game of hide-and-seek, leaving us physicists scratching our heads and wondering if they even exist at all.